algebra workshop, let me first run you through a minute or so of what we are going to go through. As we all know, algebra has become pretty important in the CAT the last couple of years, and especially this year when you see the first couple of days pattern. There's a fair amount of algebra that's turning up in the CAT. And when you say algebra, what do we mean? Basically, we mean manipulations of expressions and equations. That's basically what we are talking about. And expressions and equations of higher degree than 1. So there's a fair amount of that cropping up in the CAT. Questions of various kinds. There's quite a range of questions when it comes to algebra. So rather than the purpose of this workshop is to serve as some kind of a refresher, so that before you go for the CAT, you may be going for the CAT tomorrow, day after, one of these days, So the idea of this workshop is to serve as a refresher so that things are top of your mind when you go for the actual CAT. So that's the whole point out here. So how are we going to do it? We are going to, as always, in every aspect of CAT preparation, except for when you're learning the basics, the preferred way to go about it is to go with number of problems, right? The idea is to go with problems which we spend some time attempting, and then when we discuss them, we're going to learn, revise certain concepts and remind ourselves of how we should have approached it, the algebra behind it. That's what we're going to be doing today. Okay, so with that brief introduction, as we move on to the questions for the day. Algebra, at the end of the day, how do I put it down? It's all about there are going to be expressions, there are going to be equations, and a lot of manipulation. So let's get started on the act. The first question for the day, I'm going to leave you with the question for about a minute and a half for you to put up your answers in the chat window, after which I will be taking it up for a discussion. Now, I may even be passing the mic on to someone in case you want to say something. I have the option, I believe I have the option of passing the mic on to particular participants in case they wish to say something. You can probably raise your hand or something. There's an option like that. Just check out what options you have for communicating. Let me just check out one second. Participant. Yeah, I can see the hand raised. Yes, that hand raised is. Thank you, Vignesh. That hand raised is a symbol for me to know that somebody wants to talk to me. Okay, Vignesh, in case you want to talk to me right now, okay, yeah, that's the thing. Yeah, you've removed it. Fine. So I'll take it that you do not really want to, but you're testing. So let's start with the first question for the day. I'm going to display the first question. I'm going to give you about a minute and a half to attempt it. After which I'm going to be using the question to review some basic concepts in algebra. So here goes the first question. I really don't know if you have encountered something like this before or the same question before, but there it is. Two minutes, fine. 30 seconds left. Okay, people are trying to post answers. Yeah, time's up. Yeah, so I'm going to be. Does anyone want to tell me how to get started? Even if it's in the chat window or on the participant window, does anyone want to give some insight into how we get started? Okay. This question is one of the is a very standard and a very classic one in algebra, because at the end of the day, what do we have out here? We have this expression, or we have this equation which defines an operator. There's an operator defined out here, where it's x star y, which is defined. What is very unclear? My audio or the question, Rajeshwari? Is it the audio that's unclear or audio? Are other people finding my audio? If other people are finding my audio unclear, please say so on the chat, because it's clear for you. Okay, then those of you who are facing unclear audio, then it must please check your net speed and remove any other devices that are concurrently using your bandwidth, like a phone. Typically, phone Wi-Fi also uses bandwidth. See, there are multiple devices using the same torrent. Yes, possible. Anything that's using the same bandwidth, please remove it. Then the session becomes clearer. Okay. So we have here an operator which defines the relationship between the expression x star y is defined as given out here, and we are asked to find out. We are given a condition that x and y are greater than 0.5, then given x star x is less than y star y if. Now a key point out here to note is the if. Basically, it's a condition under which this particular inequality would be satisfied. But then to move to that, as a first step, we have to find the two expressions x star x and y star y. So that we need to use the definition given out here, and therefore we just say x star x is equal to x plus 0.5x minus x into x, which becomes 3 by 2x minus x square, which means y star y also becomes 3 by 2y minus y square. Now this is a simple expression that we can obtain immediately. This question is a classic example in algebra where the key to getting to the answer quickly is a systematic approach and a clear focus on fundamental concepts and what you may and may not do. Because what are we given here? We have two expressions, one for x star x and one for y star y, and we have a condition out here that we have to enforce on the relationship between those values. So how do we enforce this? Just put it down. We need 3 by 2x minus x square to be less than 3 by 2y minus y square. Now how do we make sense of this? Now this question again highlights to us a very important aspect of dealing with inequalities. When we deal with inequalities, we need to remember that the basic concept we use in dealing with inequalities is certain basic properties of inequalities, which are that if the product of two numbers is greater than 0, either both the numbers are greater than 0 or both the numbers are less than 0. On the other hand, if the product of two numbers is less than 0, one of the numbers is greater than 0 while the other is less than 0. So this combination has to be satisfied. These two combinations are put out here. When A, B is greater than 0, A and B are both greater than 0, or A and both are less than 0. When A, B is less than 0, one of them is greater and the other is less than 0. That's the basic principle that often gets used. But in order to do that, you're going to have to first organize this as some kind of a product. How do you do that? Here we notice that there's an x here and a y here, and x square here and a y square here. When we swap the sides, the sign is going to change and you are going to get an x minus y and an x square minus y square, which means you can get an x minus y out common and therefore get a product. That's the idea. So we move them to one side, 3 by 2 x minus y minus x square minus y square, which is less than 0, which becomes, when I take out the x minus y common, it becomes 3 by 2 minus x plus y, which is less than 0. Now this is the expression that we have to work with. So how do we work with this expression? I'm going to rewrite this expression on a fresh page. X minus y into 3 by 2 minus x plus y less than 0. Now here we have a, b less than 0. Now how does this condition work? It works with a less than 0 and b greater than 0, in which case we say x minus y is less than 0 and 3 by 2 minus x plus y is greater than 0. Now we are already told that x and y are both greater than 0.5, which means x plus y must be more than 1. But when x plus y is more than 1, the simple point is that x plus y is positive. So this number is basically 3 by 2 minus x plus y. If it is going to be greater than 0, what it means is that x plus y, while it is positive and greater than 1, it has to be x plus y must be less than 3 by 2. But if x plus y must be less than 3 by 2, if I want x to be, the first one tells us x minus y is less than 0, which means x is less than y. If I want x to be less than y and x plus y to be less than 3 by 2, I need to note that x takes the smallest value will be slightly more than 0.5, in which case y would be slightly less than 1, because okay, this must be on delta 1, this must be on delta 2, because if it's slightly more than 0.5, y must be slightly less than 1, so that the sum of x and y is slightly less than 1.5. So this is a simple principle, which means y is less than 1, but x is less than y, which means we have 1 which is greater than y, which is greater than x, which if I go to the original slide, I see is given in option 3. So this systematic approach is what is required, but the question doesn't end here. There's another option out there, which is that x minus y is greater than 0 and 3 by 2 minus x plus y is less than 0, which means x plus y becomes, oh, you shouldn't be cancelling out x minus, okay, Shivaram, this I cancelled out x minus y. Okay, that's one of the standard errors made. You do not cancel x minus y. If you do that, you miss out a very important part of the inequality. Problems on inequalities, especially when you take greater than 0, less than 0, do not cancel algebraic expressions. Each algebraic expression out there will give you a condition, and it is a combination of conditions that will give you the answer. And it's a very, very basic concept to remember in dealing with inequalities. Okay, Anirban says the last line is the deltas is not very clear. Okay, what is the concept of these deltas, Anirban? Very simply, if you say x is greater than 0.5, then x must be something slightly more than 0.5. So I put the delta 1 out there. Similarly, if x plus y is less than 3 by 2 and x is slightly more than 0.5, y2 must be slightly less than 1. The y can at most be a value slightly less than 1. Y can't be 1. Because if x is slightly more than 1 and y is 1, then x plus y would become greater than 1.5. So y has to be a shade less than 1 necessarily. That is a condition imposed on y. That 1 minus delta tells us y is less than 1. That condition is what I am bringing in out here, that 1 is greater than y. Okay. It wouldn't come x minus y minus x. Okay, Vaidyanathan says it will come as y minus x. Not exactly, because if I go back to the original expression, I have x minus x square, 3 by 2 x minus x square is less than 3 by 2 y minus y square. So when I bring all the expressions to the left hand side, it will be 3 by 2 into x minus y, not y minus x. Is that clear, my dear others? It was less than as given here. I just brought it to this side. I just brought it all to this side and changed the sign of 3 by 2y. Can you explain why x less than y? Okay, I'll come to that. Now, why is x less than y? Because, I'm sorry, this is the last question, I'm on the wrong slide. Okay, I have this product out here. In this product, I have a into b is less than 0. A into b is less than 0 in one combination. A less than 0 and b greater than 0. You take the combination. When you take the combination, a for me happens to be x minus y and b for me happens to be 3 by 2 minus x plus y. That's why. Is that clear, Maruni? And then I come to the other one. Here I have taken a greater than 0 and b less than 0. But in this case, we have x is greater than y and x plus y is greater than 3 by 2. Now, clearly, this gives us a huge range of options. But when I go to the answer choices, I find that that particular choice is not present here. Y greater than x greater than y, and the whole thing is anything of just about anything. So this is not a valid condition. This is not a valid condition. This is not a necessary thing. It's not if. Okay, it could be true if it is, but then the most appropriate condition is condition 3. If AB is less than 0, no, given as a question, if AB is less than 0, then is it A less than 0 or B greater than 0? No, two options are possible. Remember, when AB is less than 0, there are two possibilities, A less than 0 and B greater than 0, or A greater than 0 and B less than 0. Okay, the same can be applied. 1 minus D is equal to, okay, define says x equal to 1 minus D, y equal to 0.5 plus D. Define, if you go to the analysis again, I have 3 by 2 x minus x square is less than 3 by 2 y minus y square, which means 3 by 2 minus x plus y into x minus y is less than 0, right? So if I have x minus y as greater than 0 and 3 by 2 minus x plus y as less than 0, I get two conditions, x plus y greater than 3 by 2. Okay, this is the first condition I get, x plus y greater than 3 by 2. Okay, and I have x greater than y. And if x plus y is greater than 3 by 2, the problem is that both should be more than 0.75 basically. Both should be more than 0.75 since x plus y is, okay, if y goes to 0.5, x would be greater than 1. But if x cannot go to 0.5, x cannot be equal to 0.5, x can be less than 1, but then if x is less than 1, y would have to be 3 by 2 more than 3 by 2 minus x. So those are the conditions that we get. And if I go back to that thing, that I find that if this is true, see the point is, if 3 is true, whatever happens, the condition is satisfied, and that's the whole point. I repeat, if 3 is true, whatever happens, the condition is satisfied. But with all these, there are special sets of values. When x is greater than y, it is not true for every set of values where 1 is greater than x greater than y. Whereas it is true for every set of values where 1 is greater than y, which is greater than x. Ranveer, no, x can be greater than y. X can be greater than y. If you go to the last combination I've written out here, x can be greater than y. But look at the condition given here. Is it necessarily true for every value where 1 greater than x greater than y? No. I can choose combinations of x greater than y where x is less than 1, where this condition is not satisfied. Because if I go to the last slide, the combination required is a key. How is the third option satisfying a less than 0 and y less than 0? No, a less than 0 and b greater than, a greater than 0 and b less than 0. The third condition was derived from a less than 0 and b greater than 0. The third condition was derived from this combination of a less than 0 and b greater than 0. From that we got x less than y and x plus y is less than 3 by 2. Both conditions were derived from that, remember, and that's how we got option 3. No, option 3, it can't come negative solving. Please note, okay, let me repeat the working out. When I have x minus y less than, this is the last explanation, correct, next question, time for the next question. When I have this combination, please note this for the last time, when I have this combination, so x minus y less than 0, x is necessarily less than y and x plus y is necessarily less than 3 by 2. Please look at this combination and you will understand what I am saying. If x plus and on top of it I have x greater than 0.5, which means y must be less than 1. It's a necessary condition. Please note that when I see this combination, I have to have x less than y out here and I have to have y less than 1. If this is satisfied, this will necessarily be true and hence the condition will be satisfied. Is that clear? Okay, so let's move on to the next question. I'm going to give you 2 minutes again to address this question. Okay, let's start now. This is a very simple one. It should take you 2 minutes. Okay, too many answers coming too fast, so I shall not give 2 minutes for this question. I shall stop right here. So this is the basic concept in quadratic equations, which we're just reviewing. And the principle very simply is that when you talk about quadratic equations, when you talk of roots being reciprocal of each other, very simply the simple principle is if the roots are alpha and 1 by alpha, one thing we can definitely say is that the product of the roots will be 1. And we know that for any quadratic equation which is the form x minus alpha into x minus beta equal to 0, clearly the quadratic equation is in the form x square minus alpha plus beta x plus alpha beta equal to 0, which means alpha beta is the constant when the coefficient of x square is made into 1. So clearly if I have something in the form ax square plus 3x plus 6 equal to 0, I write as x square plus 3 by ax plus 6 by a equal to 0. Clearly, when the roots are reciprocal of each other, 6 by a, which must be the product of the root, must be equal to 1, which means a must be equal to 6. And that's the simple principle that we are reviewing here. So just bear in mind that in problems involving quadratics, the most commonly used principles are alpha plus beta equal to minus b by a and alpha beta equal to c by a. This principle is so extensively used that it hits the point of Boda. The sum of the roots. Okay, what about the sum of the roots? We really wouldn't be interested in the sum of the roots because it would just become alpha plus beta equal to minus of 3 by 6 once I derive it, so it will be minus half, but I really wouldn't be interested. It will be minus 3 by a because it says x square ax square plus 3x, so clearly it will be minus 3 by a, so there's no room for doubt about that because it's always minus b by a, nothing else. It's because it comes from this point that any quadratic expression can be factorized into this form, and if it is equal to 0, we come to the age-old principle that ab equal to 0, which means x equal to alpha or x equal to beta. That's how we get the roots as alpha and beta. That's how we get the product of the roots to necessarily be alpha beta, which is the constant term, and the sum of the roots is minus of alpha plus beta. The minus of alpha beta to be or alpha plus beta to be minus b by a. Okay, so let's just move on to the next question. Okay, now try this out. I'm going to give you 2 full minutes to try this question out. Okay, there we are. I think we've given enough time for this question. A lot of answers have put in, but I'm quite surprised that a lot of people have very quickly said option 2. Okay, that's a standard rule, is it? Okay. The simple principle here is that whenever we have something of the form ax plus b by cx plus d as f of x and a equal to minus b or a plus b equal to 0. So the answer is option 2. A lot of people have, okay, I get the point, Dhaval, but the point is when people post the answer, you don't know if they're posting the right answer. So don't worry too much. There will be enough cases where people will be posting the wrong answer. That's just what a person thinks of as the answer. So don't get too perturbed. Okay. Okay. So the point is, the condition here is a should be equal to minus b. And why is that so? If you just look at this carefully, when I take a, if I say f of, if I say y is equal to ax plus b by cx plus d, I just cross multiply, I get ax plus b equal to cxy plus dy. Now my basic purpose is to write x in terms of y. So I will take all the terms involving x to one side and all the terms not involving x to the other side. So I can write x in terms of y. So I would get ax minus cxy is equal to dy minus b. That's the simple expression that comes out. So I have x coming out and a minus cy is equal to dy minus b, or x is equal to dy minus b by a minus cy. Now in this, so Ranveer, I'm giving a general rule. I'm going to give you a general rule at the end of which, by just looking at the expression, you can mark the answer. That's the idea. Okay? That's what I'm doing. When you see this, you realize that if a equal to minus d, I replace this d with minus a. So the numerator becomes minus ay minus b, and in the denominator the a becomes minus d minus cy, which means to the form ay plus b by cy plus d. There it is. When I substitute y, I get x back. So f of x is equal to x. That's it. When you reflect it, it comes back to the original x. And that is the simple point, right? If Nitin has a question, any condition for c plus b, sir, or is just a plus b equal to 0 enough to prove it? Nitin, it is enough for a plus b to be equal to 0. If you notice, that is all the conditions that I have applied out here. A mere a equal to minus b was enough to allow me to replace it as minus ay minus b by minus d minus cy. Okay, Subhanin has a question, is applicable for this question only? No. As long as a is equal to minus b, in fact, you could make it 2x plus 10 by 5x minus 2. It will still work. Just change it and see for yourself. As long as a is minus b, this expression, this concept will work. Okay, and there's a very basic principle of this reflecting function, because this symmetric function, you come back to the original function itself, that f of x equal to x, especially in these algebraic fractions. C does not necessarily equal b. No. C does not necessarily equal b. Nothing or no relationship needs to exist between b and c. It's only between a and b where a plus c must be equal to 0. So in this question, coming back to the point, Ranveer, you see, since this is 2 and this is minus 2, I automatically mark this as the answer. Omit this, because it's 3 and minus 5, 2 and 4. I omit these and say option 2 is the answer. That's why Ranveer. Oh, Ranveer, okay, Rajiv, the simple point is, when I land up with an expression of the, when I land up with an expression of the form dy minus b by, let me go to the question thing, it is a minus cy, right? By a minus cy. Now look at this, in the numerator I have a b, in the denominator I have a cy. It's only these two terms that are troubling me and I want it to mirror. I want it to mirror, right? So if there's one condition in which I can make it look, and I look at the minus sign here and a minus sign here, right? So if I want to make it a mirror, I just apply that condition which brings me back to that original expression. By doing this, I get something of this form. That's why this is an observation. It's an observation we make in that particular condition. That's all. Okay. Amir has a question. Do we need to check? Actually, if you see A equal to minus B, you don't need to check, Amir. You can just go ahead and mark. A equal to minus B is enough. It's enough of a red rat to the bull for you to go ahead and mark that answer choice as the correct answer. Don't waste your time, because if you save time out here by understanding this principle and therefore not checking for it, you get the time to invest in other questions. Just remember, that's critical in the CAT. The key to understanding some of these principles is that you save time. Okay, so is it true if and only if A plus B is equal to 0? It is true if A plus B equal to 0. It is true if A plus B equal to 0. That's all. I'm not worried about B and C. Yes, it will work only for Ax plus B by Cx plus D. That's the only case for which it will work here. It works for something of the form Ax plus B by Cx plus D. Okay, so Sundar, I hope I have answered your question. Okay, so let's move on to the next one. Can there be Ax plus B by Cx plus D without A plus B equal to 0 but still be a self-impulse? No, not possible. To the best of my knowledge, it won't be possible. Because it is that A equal to minus B that cancels out all the constant terms in the numerator and cancels out all the x terms in the denominator. That is why that particular aspect eliminates and it makes the coefficient of x in the numerator equal to the number you get in the denominator, as a result of which you get a standalone x as the expression. Okay, Manish is saying we can solve this question. Manish, my point is you don't even try to solve this. My point is you just look at the sign of A and B and mark the answer. I'm saying don't even try putting x equal to. Okay, but then there is always the point that what if I don't know the principle required at that time? Then okay, substitution is fine. Okay, so let's move on to the next question. Oh, I'm sorry, this question I'm skipping. I'm going to this is the next question. Hemant, I don't know if it's a CAT question. Dhaval, why worry? There are so many different answers you're seeing there. Okay, let's get the point straight here. What is the point here? This is a question where we are quickly revising some basic concepts in functions and graphs. We are talking of how many times a curve intersects. A straight line and a curve will intersect number of times depending on how many times the curve turns around. So the straight line keeps going in one direction. A straight line can cut something like a parabola only twice at most. A cubic can be cut thrice. A biquadratic can be cut 4 times. So that's the basic principle out here. So a lot of it depends on how many, what is the kind of curve and how many times it's actually turning, right? So that is the basic principle out here. Okay, so what is the idea here? The idea here is we are looking at two curves. I will drawing the axis quickly. I have two curves, one which is a straight line y is equal to x minus 1, y is equal to x minus 1, basically when x equal to 0 is y minus 1. So I have a curve that will go like this. And it is necessarily going to make a 45-degree angle with the x-axis. That's the basic principle out there. That's one of the curves. What's the second curve? Y is equal to log x to the base 10. Now, how do we quickly plot log x? Very simply put, when x equal to 1, log of x equal to 0 for whatever base. So this curve is going to intersect the x-axis at 1. What happens after that? Beyond that, the curve drops to minus infinity. And above that, the curve will necessarily go this way. How do we know that? Very simply put, if I take a simple example, when x equal to 100, log of x to the base 10 is going to be 2. Whereas when x equal to 3, y equal to x minus 1 will be equal to 2. So when x is equal to 3, log of x to the base 10 is going to be far less than 2. Right? It's going to be far less than 2. So it's going to be below the other curve, which means it's going to turn around, right? And again, when I go below, it's going to go the other way. It's going to go the other way because if I just take x equal to let us say half, x equal to half means y is equal to minus half with x minus 1. Whereas with log x, it is minus 1. So it starts falling faster than y is equal to x minus 1 falls when x is less than 1. It rises slower than y does when y is equal to x minus 1. So this is how the log function, the curve of the log function will go. Now please note that I am being very careful to avoid anything to do with calculus and explanations like that while explaining this to you. Okay, Hemant wants me to repeat. The concept here is that y is equal to x minus 1 is going to be a straight line with a fixed slope. It's going to keep going up at a certain rate, right? Whereas the log x is going to be a curve. The question is, the number of times it's going to touch will depend on the shape of the log x curve. We know that they're going to touch at x equal to 1 because at x equal to 1, x minus 1 and log x are both 0. The only question therefore is, how does the log curve shape itself turn apart from that point? Yes, x minus 1 is basically a tangent to log x. That's what comes out, Sayuj. So, but then the point, how do we realize that? We realize that it's just some simple numbers. As I said, when you take x equal to 10, log of 100, log of 100 to the base 10 is 2. But y taken as x minus 1 would be 99. So when it's 100, this would be at 2 and this would be at 99. So clearly this straight line is going to be above the curve on this side. At every point, it's going to be above. So the curve has to bend downward above the x-axis. Below the x-axis, I took the simple example of x equal to half. Hemant, are you watching this? If x is equal to half, y as x minus 1 would be minus half on a straight line. But on log x, log of half is minus 1, which means the log curve falls faster than the x minus 1 curve for x less than 1. Is that clear, Hemant? Vignesh, you can equate the two equations. My point is that I know that they intersect here. If I get an idea of the shape of the curve, that's enough for me to answer. Usually, the way they move to the left and to the right gives me a clear answer. That's all. If they touch at one point and one curve rises slowly, slower than the other side on one half, and falls faster than the other, than the same line on the other side, we know that's only one point of touching because the opposite bending is not going to happen. So a visual way is often easier to handle than writing equating, because when you equate, you get into all kinds of, you've got to solve it, right? So that is the whole point out there. It can be done, Vignesh, it's not a problem. Where is log x equal to 0? Log x is equal to 0 when x equal to 1. Log x equal to 0 when x equal to 1. Log 0 has a value. Log 0 would be minus infinity actually. It would, log 0 is not defined actually, and we say minus infinity. It's not defined at all. Oh, sorry, 0.3010. Oh, yes, correct. Log of 1 by 10 is minus 1. So where am I goofing up? Oh, I think I just moved to log, I think base of 2 from 10. So where does it go from there? Okay, then it basically means, have I goofed up, guys? I think Harsh is pointing out a basic point. I think I've goofed up slightly in that. Let me check it out. I know that the curve would go like this. I know that out here it would look like this. It would touch here. And I think Harsh is right. It probably would go like this, and you would have 2 points of intersection. Is that what you're saying, Harsh? Question says, let me go to the question. Correct, that's a good point. I'll look at the question. Yeah, when x is greater than or equal to 1, Harsh. Okay. X is greater than or equal to, forget it. This lower part, I'm wrong on the lower part, it should go like this. Harsh is right, it would go like this. My mistake is here in taking minus 1, because I think I by mistake switched to a base of 2 mentally. I switched to a base of 2 and said mentally it's minus 1, that's correct. Harsh is right. The curve would go above and it would intersect a second time between 0 and 1. But since it says x greater than or equal to 1, the answer would be only 1. Okay, so that being the case, let's move on. Okay, now let's take a look at this next question. Again, 2 minutes for this question. Intersection is at x equal to 1, Rajesh. Touching is also considered an intersection. In fact, it's actually cutting. It's not even touching, as Harsh pointed out correctly. Okay, there have been enough answers, so stop it right here. So what do we have here? A cubic expression and a quadratic expression, and we are asked to find out when do they intersect. Intersections of two curves happen when if I say this is f of x and this is g of x, intersections happen when f of x is equal to g of x. At the intersection, the values of the two functions are the same. The what do we call it, the range, the value of the LHS based on the independent variable, they must be equal. So we have x cube plus x square plus 5, which must be equal to x square plus x plus 5, which means my x square term gets cancelled, the constant term gets cancelled, and I have x cube minus x equal to 0, which leaves me with x into x square minus 1 equal to 0, which becomes x into x minus 1 into x plus 1 equal to 0. Now clearly, when a, b, c is equal to 0, a equal to 0, or b equal to 0, or c equal to 0, this is a basic standard method of solving, which means either x equal to 0, or x minus 1 equal to 0, which means x equal to 1, or x plus 1 equal to 0, which is x equal to minus 1. So these are the basic three solutions that we get. Therefore, since I get three values of x for which the two functions are equal, there must be three intersections, and hence the answer is option 4. So please don't, there are two mistakes we should not make. One is underestimate the cat, the other is to overestimate the cat. There are questions which actually appear in the cat. Even this year there have been questions that have been at this level, questions that have not been so difficult that you can't touch them. Okay, who has a question? Karthik, should x necessarily be an integer? Karthik, here it need not be, but here I'm just solving. Right, and it says in the following is true in this range. All three values 0, 1 and minus 1 come within the range. So here all three would get selected even for the given range of values of x. Okay, and that's the important point. So don't get too perturbed thinking, "Arey, this looks simple." Yeah, the idea is not to scare you, right? If I wanted to scare you, I would be taking a different set of questions. The idea is to get a grip on a range at the level of the cat. There are also more challenging questions which will come to subsequently. So let's move on. Okay, 2 minutes to attempt this. Okay, time is up. So let's quickly move on to studying this question. So how do we address this? So we have, again, we're back to the basics of quadratic equation, where if alpha and beta are the roots of a quadratic equation, then alpha plus beta is minus b by a, and alpha beta equal to c by a, that being the rule. Here we are given two quadratic equations, one with alpha and beta as the roots, and the other with gamma and delta as roots. And we are told that if alpha cube plus beta cube is equal to gamma cube plus delta cube, we are supposed to find the values of the unknown, some of the unknowns q and r in the two equations, right? So how do we proceed? From scratch. So what do I have here? I have alpha plus beta. Alpha plus beta to be 7, alpha beta to be q, and I have gamma plus delta to be 1 and gamma delta to be r. This is a simple point out here. And what do I have here? Alpha cube plus beta cube, which becomes alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta. So once again, this is a basic identity that alpha cube plus beta cube is alpha plus beta whole cube minus 3 alpha beta and alpha plus beta. So with the knowledge of alpha plus beta and alpha beta, I should be able to find this expression. And the same works for gamma plus delta, which means 91 is equal to 7 cube minus 3 into q into 7, or 91 must be 343 minus 21q, or 21q is equal to 252, or q is equal to, minus 252, sorry. 21q is equal to minus 252, or is it 21, is it correct? Plus. It is plus 12, right? It is plus 12. Okay, then what is the next step out there? We come to gamma and delta. So where does that come from? So 91 must also be equal to, what is this? Alpha plus gamma plus delta is 1, so 1 cube minus 3 into 1 into r. That's it. 3 into 1 into r, because gamma and delta is r. So right there I have 90 is equal to minus 3r, or 3r, r is equal to minus 30. So clearly q plus r is 12 plus minus 30, which happens to be minus 18. So that is not a long process, Roshni. If you notice, it is once you recognize these identities, it is a certain set of systematic steps. Okay, but the important point is for you to note that in the CAT, if you skip questions that you don't do, Subhani, yeah, why not? There have been questions of this kind in the CAT in the past, and even there have been questions of not this kind, but questions which require this kind of application of multiple principles of algebra. You have the quadratic equations, you have standard identities, and then you have you're mixing the two. You're writing the identities in terms of the expressions that you get from a quadratic, right? So that is the basic point. Okay. So they do pop up questions of this kind, and you have to be systematic in working towards the answer. That's the key in this kind of a question. A cube plus b cube is equal to a plus b into a square plus ab plus b square. Yes, Hemant, but the key question, Hemant has a very valid point. He says a cube plus b cube is also a plus b into a square plus ab plus b square. But Hemant, the key point is, what do I have? I have a plus b and ab. From that, I want to get a cube plus b cube. The easiest way is this identity. This is the easiest identity with which you can move from alpha plus b. It's the same Vikram. Who said that is the same? Same thing was Karthik. Yeah, Karthik is the same thing, but the important point I'm making is for someone who's trying to do that, given that you have alpha plus beta and alpha beta, it works out easier from this expression because it's substituting for alpha plus beta here and here and alpha beta out here. That's why it becomes easier. Okay, so easier to implement. Okay, so let's move on to the next question. I'm going to give you 2 minutes. I'll come to that shortly after the time for this question. Um, Rajvi, sorry, the message was meant for Soumya Mishra. I wrong selected the question move. Okay, that's why it came to you wrong. Okay, okay. Let's move on. Before I move on, I think Arpan had a question on the previous one. Arpan Ghosh had a question. Last part, I'll just go to the previous question for a second, for a fleeting second. Arpan is very simple. I got Q as 12 and R as minus 30. The question requires me to find Q plus R, which means it's 12 plus minus 30 minus 80. That's all, Arpan. Okay, so let's move on to this particular question. So how do we deal with questions involving modulus? This question is absolutely a standard one when it comes to dealing with modulus. How do we deal with questions with modulus function? The modulus function, very simply, modulus of x is x when x greater than 0 and minus x when x less than 0 and 0 is 0, right? So you have to basically take the different in different intervals, each of these modulus functions will take a different form. For example, an x is less than minus 1. Why do I take it? Because the x is less than minus 1. Between minus 1 and plus, between the less than minus 1 minus delta and minus 1 plus delta, this modulus function will change form. When x is less than minus 1, it is minus of x plus 1. In which case, this becomes minus of x minus 2, it becomes 3 times 2 minus x. And this becomes 4 minus x, which becomes 5 times 4 minus x is equal to 20. So if I say x is less than minus 1, I get minus x minus 1 plus 6 minus 3x plus 20 minus 5x equal to 20. Cancelling the 20 out here, I get minus 9x is equal to minus 5 or x equal to 5 by 9. Now what is it that I get here? I started off with x less than minus 1 and I got x equal to 5 by 9. These two are contradictory. X cannot be both less than minus 1 and equal to 5 by 9. So this is not a valid range. I don't get a valid answer in the range x less than minus 1. So I do not have a solution in the range x less than minus 1. Then I take x lies between minus 1 and 2. That is the range in which I take it. In which case, modulus of x plus 1 becomes x plus 1. Modulus of x minus 2 becomes 2 minus x. And since it is less than 2, modulus of x minus 4 becomes 4 minus x. Okay, what is the, Rajesh has a question, what is the problem with x equal to 5 by 9? Rajesh, the problem is not x being 5 by 9. The problem is x simultaneously being less than minus 1 and equal to 5 by 9. How can something be less than minus 1 and equal to 5 by 9 at the same time? Not possible, right? That's why. Okay, now if this is equal to 20, what do I get? I get x plus 1 plus 6 minus 3x plus 20 minus 5x equal to 20, in which case the 20 gets cancelled and I get a 1 plus 6, 7. So I get a 5 plus 3, 8 minus 1. So I get minus 7x equal to minus 7 or x equal to 1. Now this is a valid answer because x equal to 1 does not contradict the range minus 1 to 2. The range is not contradicted. So I am quite fine taking the x equal to 1 as a valid answer. How come second modulus becomes 2 minus x? Because when x is less than 2, modulus of x minus 2 is equal to 2 minus x. That's the way it works. When x is less than 2, it's always minus of x minus 2. That's why I've replaced it like this, because it's less than x is less than 2. In the third range, I had to take 2 less than x less than 4, in which case it becomes x plus 1, 3 times x minus 2. Now it remains x minus 2 because it's greater than 2, plus 5 times 4 minus x is equal to 20, or x plus 1 plus 3x minus 6 plus 20 minus 5x equal to 20. So the 20 gets cancelled and I have 4x and minus 5x, so I have minus x, and I have 1 minus 6, so I have minus 5, and that is equal to, so I get x equal to minus 5. But I have a problem here. X cannot be equal to minus 5. Why? For the simple reason that I have taken x to lie between 2 and 4. So that's not a valid answer. So the last part of the range, I'm going to remove the top part. I have to go through it. This kind of systematic effort is absolutely essential to solve this kind of problem in modulus. Without that, you cannot get close to a solution. So I have to take x plus 1, 3 times x minus 2, plus how you are getting the expression after assuming a range. Okay, Aditya. Aditya has a question. Okay, please post all questions to all participants. Right now, Aditya, I'm going to copy your question and post it to all participants so that everybody knows what I'm asking. This is Aditya's question. Hemant, yes, it is time consuming, but you don't have an option. Okay, Aditya, the point is, I have to take different ranges because in each range, each of these modulus functions takes a different expression. So I write it out, I solve, and I get a value. Like in the second case, I took minus 1 less than x less than 2, and I solved and found x equal to 1. Now I do not find any contradiction between this assumption and this solution. So the solution fits the assumption and hence is valid. If for x less than minus 2 the result holds good, what would be our approach next? How do we find the sum then? I would take that x also as a valid answer defined. Okay, that is the whole point. When x is less than minus 1, you get 1 minus x, or no, you get minus of x plus 1 Vikram, never 1 minus x. Modulus of x plus 1 becomes minus of x plus 1, always. So coming back to complete this, 5 times x minus 4. Now this becomes x minus 4 when in the last range x is greater than 4, and when this is equal to 20, I get x plus 1 plus 3x minus 6 plus 5x minus 20 equal to 20. So I have a plus 1 minus 6 minus 20, so minus 25, so 45. So I get 45 on the right hand side, 1 plus 3 plus 4, 9x. So I get x equal to 5. Now x equal to 5 does lie in the range x greater than 4. So this is a valid answer. Therefore, I get x equal to 5. I already have x equal to 1. The sum of the possible solutions is 5 plus 1, 6. So a problem involving modulus necessarily involves this kind of systematic approach where you look at every range, and in every range you have to open up each modulus as it should be done. It's not 4. There are not, yes, there are a total of 4 cases, but in only 2 cases do we get a valid answer. In 2 of the cases, the answer we get contradicts the range in which we have assumed x to be. Can we deduce that CBD is never possible? Yes, you can do that. CBD is not possible in a modulus function. It can be determined. Which part will not follow, Sanghavi? Why is minus 5 cancelled out here? Okay, good. Sandeepan, the point is when 2 is less than x less than 4, how can x be equal to minus 5? Can x lie between 2 and 4 and be equal to minus 5? It can't be, right? That's why we eliminate it. Any shortcut? Not that I know of. How is x equal to 1? X equal to 1 is a valid solution, Sandavi, when I deal with x being in the range minus 1 to 2. When I take x in the minus 1 to 2 range, x plus mod of x plus 1 becomes x. I'm out here. Mod of x plus 1 becomes x plus 1. Mod of x minus 2 becomes 2 minus x. And mod of x minus 4 becomes 4 minus x. So when I substitute them, I solve and find that x becomes equal to minus 1. But x equal to 1 does not contradict x lies between minus 1 and 2. That's why I take it as a valid solution. How to decide which values ranges to take? Good question, Srija. Look at the expressions. Here I have modulus of, here I have mod x plus 1, mod x minus 2 and mod x minus 4. The moment I see this, I know this tells me minus 1, this gives me 2 and this gives me 4. So if I take it on a number line, there is minus 1, 2 and 4. So I have to see in this range, in this range, in this range and in this range. Is that clear? Who was that? Hemant. CBDs cannot be determined. Okay, Sayuj has a question. You give 2 minutes. Okay, Srija asked how to decide the value. Srija, I hope you're clear now. Okay, yeah, good. So there is no option. You just have to go ahead and take. In the moment you see mod expressions, decide which ranges you're going to test in. Without that, you cannot proceed with these questions. Okay, that's an absolute requirement. Okay, let's move on to the next question. Solve for Karthik. Are you giving me a problem? No, I'm not going to do that now. I'm not going to do that. I'm going to take something else in modulus. Yes. 2 minutes again. Vishnu will answer your question once this attempt is done. Okay, a lot of people have answered it, so I'll stop it here. Okay, so before that, in the previous question, 2 people had the question. Okay, who was that who asked the question last time? One more guy, I think Anirban had the question. Why don't we check for 1, 2 and 4? Now one more person has asked the question. It's not that we don't check for 1, 2 and 4. Okay, I'm going to the previous question for a minute. It's not that we don't check for 1, 2 and 4. The way the modulus function actually works is mod x equal to x for x greater than or equal to 0 and equal to minus x for x less than 0. So it's included out here. It's included at the lower end of the range, of the positive range, remember. Okay, so that's where it's included. So it's not that we have excluded it. I took that range and I found the range to be something different from the extreme value. That's all. Okay, so let's get to this. So what is the idea here? The idea here is very simple. How do these functions work? When I take modulus of x minus 10, modulus of x minus 7, I take this combination, modulus of x minus 4, modulus of x plus 1, and modulus of x plus 4. Now, how does this, is going with options the best choice out here? Yeah, you could. Actually, there's no harm in going with the options, because if you put the options, you get 10 plus 7 plus 4 plus 1 plus 4, which becomes 9 plus 7, 16, 26. And for x equal to 4, it becomes 6 plus 3 plus 0 plus 4 plus 8. So this is 12 plus 9, 21, and so on. But if none of the above, yes. Okay. So very simply, the point here is there are 5 different values, 5 different modulus functions. I've given them in increasing order from in terms of what's inside, x minus 10 all the way to x plus 4. So clearly x plus 4 must be greater than x minus 10, so they're in ascending order. Okay, so very simply, if you arrange them, it's a deviation. It's a deviation that we're interested in. So the median would have, when you take x equal to 4, all these will be reduced. I have taken the largest possible value of x and the smallest on this side. So what happens is that deviations on either side become smallest, and the expression inside every modulus takes the smallest possible value. That's the idea. That is why when I take it as it is, I would get, if I take for example 7, I get 7 minus 10, 3, plus 7 minus 7, 0, but 7 minus 4 is 3, 7 plus 1 is 8, and 7 plus 4 is 11. The deviations on the x plus 4 side become much larger. Okay, so the deviations on the other side become much larger. If I take x equal to minus 4, the deviations on this side become much larger. X minus 10 becomes minus 14. That's the whole idea. Okay, so don't worry, Anirban. I realize. So that's why the deviations around the median are closer to the mid-range. The one in the middle, every deviation, the sum total of the deviations becomes the lowest. Otherwise, there are significant deviations. So take the center value, arrange them in ascending order. Take the middle one. If there's an even number of terms, how to find the minimum or maximum? Okay, see, modulus function of this kind with all positive signs would typically have only a minimum value. Correct, Hina, what happens if you have even number of terms? Take the middle 2 terms and take something in between the range. Take the value in between the range. That's what would work. Take something between the range, because that would, in that range, the one side would be positive and the other side would be negative, and the range would fall net. Okay, so if you have even number of terms, let's say you have 4 terms, take the second and the third term, the 2 numbers that they give, take something in between. Okay, no, just look at the numbers out here. It's not the median method, it's the median, it's the concept. The concept is that when you look at x minus 10, looking at how much it deviates from 4. How much this thing deviates from 4? It deviates by, x10 deviates from 4 by 6, right? This deviates from, 7 deviates from 4 by 3. Again, x plus 1. X plus 1 is 4 plus 1, so the deviation is to the extent of 4. Right? Whereas this deviation gets knocked out and it takes x equal to 0. That's the simple principle there. Okay. So Harsh, it depends on the sign. Harsh says maximum is not possible to find. If you look at minus signs out here, it's possible. I mean, it depends on how the function goes. There could be a local maximum where it turns down. Okay, that's exactly why. Okay, so let's move on to the next question. Yeah. We're already at 10:45 and I have at least 5 more questions to cover. Okay, I'm going to stop the timer here. So how does this work out? What is the concept here? This is a case of rewriting, basically somewhere rewriting into products. AB equal to 4A plus 5B means AB minus 4A minus 5B equal to 0. So how do I get AB, 4A and 5B in the same expression? To get that, I add 20 to both sides, in which case it becomes A into B minus 4 plus 5 into B minus 5 into B minus 4 equal to 0, or I get A minus 5 into B minus 4 equal to 0, equal to 20. So in this case I have 20 on the right hand side, and therefore I have this product of two terms, A minus 5 and B minus 4 being equal to 20. Now at this point we drag in the principles of numbers. I have two numbers that multiply to give us 20. How is that possible? 20 equal to 2 square into 5, which means there are 6 factors and 3 ways of writing it as product of 2 factors. And the important point here is those of you who said 1 didn't realize that if 5 into 4 is 20, 4 into 5 equal to 20 is another pair possible. Why is 20 and 1 not possible, listener? Why is 20 and 1 not possible? Why can't A minus 5 be equal to 20 and B minus 4 be equal to 1? Then A would be 25 and B would be 5. I have no problem with that. Absolutely possible, right? That's okay. That's a mistake we can easily make. Fine. What do we see here? The important point here, for A minus 5 equal to 5 and B minus 4 equal to 4 is different from A minus 5 equal to 4 and B minus 4 equal to 5. So these are two distinct answers. So while I can write it as product of 2 factors in 3 ways, since swapping gives me a distinct answer, the answer is twice 3, that is 6. Okay, because as I said, if 5 is to 4 is a factor, so is 4 is to 5. If 1 is to 20, no. It says how many solutions are possible. Ranveer, please note, it doesn't need to be mentioned ordered pair. It says how many solutions. Solution means ordered pair A comma B automatically. It doesn't need to be mentioned. It doesn't need to be mentioned out here. Anirban, which part? 4 into 5 and 5 into 4? Is that the part? Okay. So when it's A minus 5 into B minus 4. Okay, I've got, if it's clear up to this stage, all I notice is that B minus 4 is common and I take it out to A minus 5 into B minus 4. So once I do this, I have two numbers that multiply to give me 20. So I have 2 factors of 20, 20 being written as a product of 2 factors. And that can be looked at by looking at the prime factorized form of the number 20, which is 2 square into 5, which means there are 2 plus 1 into 1 plus 1, that is 3 into 2, 6 factors, and therefore I can write as 1 into 20, 2 into 10, 4 into 5, and the point is 5 into 4, 10 into 2, and 20 into 1 are also valid solutions where the values of A and B obtained out here would just be swapped. That's fine by us. That's absolutely fine. But we have, or not swapped, but I will get a different set of values. Right? So I know that I will get 6. By just looking at this set of 6, I get, it's just the number of factors simply because I can swap them. Simply because swapping is a different solution. When do we take 3? When do we take 3? You would never take 3. It says how many solutions. As long as A and B are distinct positive integers and we're talking of solutions, you would have to take both the values. How many ordered pairs? The ordered pairs is the same as how many solutions, because every solution is an ordered pair. The answer is option 4, 6. How can 1 and 20 satisfy? Why won't 1 and 20 satisfy? I want A to be 1 and B to be, I don't want A to be 1 and B to be 20. I want A minus 5 to be 20 and B minus 4 to be 1 value. Please note. AB equal to constant is the equation of a hyperbola only. Let's not get worried about what shape the curve will take. We are just worried about the solution to this. Okay. Karthik says for all values B greater than or equal to 5, I get positive value for A. So in fact, where am I going wrong? A is equal to 5B by B minus 4. No, Karthik, there is not necessarily an integer. Karthik, in what you have written, Karthik, when you say A is equal to 5B by B minus 4, B is not necessarily an integer. I have to enforce the condition that A and B are integers, especially A is not necessarily an integer if we take it that way. I'm sure what's your question? How can we take AB as 10A plus B? How can you take it? How can you take AB as 10A? No, you're talking about the number. No. You have to take it as A into B. Otherwise, it doesn't mean much. For a positive integers, when you say positive integers, then it doesn't mean much for positive integers. I can give one solution, one ratio, and I'll have just too many answers possible. Is that clear, Vishwanath? AB cannot be taken as a two-digit number for that reason, because they have infinite solutions automatically. Would it change if we take? No, it won't change, Vikram. It won't change. You will just get 4 plus A into 5 plus 4 minus A into 5 minus B. That's all. It won't change anything. Okay. So ordered pair and solutions are the same. Yes. Every solution is an ordered pair. 4A plus 5B minus AB. How does it become 4 minus A, 5 minus A into 4 plus B? 5 minus A, Vikram, please note, it says 5 minus A into 4 plus B, you have 5B and minus 4A. You're wrong there. Please note, Vikram, you're making a mistake there. Okay, that's one. Okay, so don't get any, if we don't get any common factors, then if it's only a prime, you will find something, don't worry. Even if it's only the product of the two numbers, here it's just the product of 4 and 5. Shruti has a question, is the question of numbers or algebra? It's both, Shruti, it's both. That's why we included it. Okay? How do you decide to add 20? Because I have 4 and 5, that's all. Okay, I have 4 and 5, so I add 20. Okay, let's take the next question. It's a very basic question to review a concept. I'm going to give you only 1 minute. Okay, this shouldn't take too much time, so stop it right here. What is the principle there? Arithmetic mean is A plus B by 2. Geometric mean is root of AB. Harmonic mean is reciprocal of the arithmetic mean of the averages. So if I basically take 1 by A plus 1 by B by 2, so it becomes 2AB by A plus B. Right? So it becomes twice GM squared by arithmetic mean. Right? So which basically means GM squared is equal to, GM squared by arithmetic mean. No 2 out there. So GM squared is nothing but AM into HM, which means HM is equal to GM squared by arithmetic mean, which in this case is nothing but 4 square by 5, 16 by 5, 3.2. That's all. So this is just to revise the basic concept of the relationship between arithmetic mean, geometric mean, and harmonic mean. So please bear the simple principle in mind that Gm square is equal to Am into Hm. So with this in mind, a lot of questions involving these means, these three means can be handled very, very easily. Okay. So as I said, this is not meant to be a difficult one. It's just a reminder of a concept you're supposed to revise at this stage. Okay. The next question. Okay, all these are cube. I'm sorry, this is A cube, B cube, C cube, A power 5, B power 5, C power 5. Please bear that in mind, C square. Okay. I'm going to give you 3 minutes to attempt this. Okay, since there are a lot of answers, I'll stop it right here. So how does this work? Okay, this is just a lot of donkey work because I know A plus B equal to plus C equal to 0 means A equal to minus of B plus C. So this is where I start, which means A square plus B square plus C square is minus of B plus C the whole square. It means it's B square plus C square plus 2BC plus B square plus C square, which means it is twice B square plus C square plus BC. Now I go to the next one, A cube plus B cube plus C cube. A cube is minus of B plus C the whole cube, so it's minus of B cube plus C cube plus 3BC into B plus C plus B cube plus C cube, which makes it minus of 3BC into B plus C, which means it is twice 2B square plus 2C square plus BC minus 3BC into this whole thing into minus 3BC into B plus C. So this is the expression we have out here. Okay. Now what about the denominator? Denominator is just A power 5 plus B power 5 plus C power 5. Now A is equal to minus of B plus C whole power 5 plus B power 5 plus C power 5. And if I remember the binomial expansion for power 5, it's 1, 5, 10, 10, 5, 1. This is the expression 1, 4, 6, 4, 1 then becomes 1, 5, 10, 10, 5, 1. These two get cancelled because minus B power 5 minus C power 5 will get eliminated with B plus B power 5 plus C power 5. So it becomes 10 minus 10 B power 4 C minus 5 minus 10 B cube C square minus 10 B square C cube. Correct, it's very lengthy. Minus 5 B C power 4. Now this expression has a 5 common, minus 5 common, so I have B power 4 C minus plus B cube C square plus 2b cube c square plus 2b square c cube plus bc power 4. Let me take this expression to the last page. Minus 5bc into minus 5bc into b cube. Okay, now I get the pattern. B cube plus b square c, 2b square c plus 2bc square plus c cube. If this is what I get, what does b cube plus c cube become? B plus c the whole cube minus 3bc into b plus c, and this becomes 2b square c 2 plus 2bc into b plus c, right? So I have b plus c the whole cube 1 0 minus 1. Okay, so if you underline, actually this is not the kind of question you would do in a paper. If you ask me frankly, I wouldn't answer this question in a paper. Even in this year's CAT, there were enough questions of this kind which I didn't answer, and I still found this many questions to do. Please bear in mind, I did not do many questions of this kind. You can check with numbers, but with numbers you can't be certain. Yes, I could find 22 questions to do. And in fact, I was supposed to do only 15, so I left it at that. I answered only 15 and removed the remaining 7. Do you suggest us to attend this type? Frankly, no. Frankly, no. But if you can see, there's a kind of effort involved. You cannot eliminate this kind of effort in this particular question, right? It's impossible to eliminate it. So now I have b plus c common. I take the b plus minus. I have 5bc into b plus c. I think this is what I get. And then I will take the b plus c common, and then I work with it again. So it comes to 6 by 5. Substitution method can work, but you can't be certain of the answer. Okay, so that's the whole idea. So it's a lot of labor for very little, very small outcome, which is the same 1 mark that you get in any other question. So personally, if you ask me, this is the kind of question you skip. Okay, but at least you see that this is the kind of effort we just use various identities to simplify the question. Okay, so let's move on to another question. Now this is the question that's actually come in a SAT paper. Just try to answer it quickly. Typical functions and graphs. Rajesh, you could miss out something in substitution. Okay, a lot of people have answered, so I'm going to move on with this question because it's just supposed to be answered by observation. So what is the point here? We're asked to find the number of roots of f of x equal to 0. As an equation f of x equal to 0, and I'm supposed to find the number of roots. But how do I go to the number of roots? f of x. For that, I first need to understand what are the values of x for which f of x is 0. Which means I have 1, 2, 3, and 4, right? That is the basic point, right? That is the starting point. Now, f of x means for the values of f of x, for the values of x for which f of x becomes 4, 4.5, 8, or 9, I will get a solution. which means I have to look at every value of f of x for which I would have a valid value. So what happens here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So how many do I have? 12. That is option C. Okay? Okay. I'll clear this out. Basically, see, functions and graph quizzes do not involve a lot of donkey work. It involves careful looking at the curve and interpreting it well. Okay, so what do we have here? You want f of x equal to 0. You first have to know when f of x is 0, right? By observation, we know that the points I'm marking out here, 4, 4.5, 8, and 9 are the points where f of x is 0. But if I'm going to put f of x, I have to take those values of x for which f of x becomes 4, 4.5, 8, or 9. Right? For those values, f of x will become 0. Because I know f of 4, 4.5, 8, and 9 becomes 0. So I need f of x to be 4, 4.5, 8, or 9. Okay, but therefore I have to start looking at, okay, where does f of x become 4? When I draw the horizontal line, it comes somewhere here. And where does it become 4.5? Somewhere here. Right? So what do I find? I find 1, 2, 3, 4, 5, 6 points along f of x equal to 4, and 1, 2, 3, 4, 5, 6 points along f of x equal to 4.5. That's it. What about 8 and 9? Good question, Yogesh. Do I see f of x becoming 8 or 9 anywhere in this interval? No. So there are no zeros, no values for f of x equal to 9, and f of x becomes 8 or 9. It can't be attained, as Souvik says. It will all fall above the graph. So I don't worry about 8 and 9. That's all. Okay, so this is a basic lesson in functions and graphs. Observe the graph carefully, understand the proper meaning of what is asked, and then figure out how you look for the answer from the graph. There's no work at all. Just looking carefully at the graph will give you the answer in double quick fashion. Why not 8 and 9, Hemant? Because I don't get f of x equal to 8 or f of x equal to 9. Where is f of x equal to 8 or 9? This is 8 to 9. Can you see a single value of the curve inside 8 and 9? If it's f of x. Oh, that's too many layers. Then I need f of x to be 4 or 5. So that's not so easy. Sir, go 2 levels. It's too difficult. I would skip the question. Okay? So let's move on to the next question. 2 minutes again to answer. Okay, I've seen enough answers, so I'm going to move on. I'm going to stop this question here. Okay, so how does it work here? Minimum value of a quadratic expression. The first and foremost point to understand is that the shape of a quadratic expression depends on the sign of the coefficient of x square. And since it's positive, it's a curve that goes upwards. And x square minus 4x minus 5 is x minus 5 into x plus 1, which means it cuts the x-axis at 2 points. It cuts the x-axis at 2 points. One is at x equal to 5 and x equal to minus 1. So it's a curve that goes like this, 5 and minus 1. The next point to understand about quadratic expressions is that the minimum occurs exactly between these two, which means it occurs at 3, which is where some people got tempted and said 9 minus 4 into 3 minus 5 to get 17. Was it 12 plus 5, 17 minus 9? Is that what you did? Looks like 8. 19 minus 9, 8. I don't know why you people mark 9, but clearly that's not the answer. But for those of you who didn't do that, or didn't get a grip on this, what is the next thing to do? The next thing is that we see that the mod function is being used. So if 2x plus 5 mod of 2x plus greater or equal to 10, then it's either 2x plus 5 greater than or equal to 10, which means x is greater than or equal to 5 by 2. But 2x plus mod of 2x plus 5 will be equal to 2x plus 5. Mod of 2x plus 5 is equal to 2x plus 5 when x is greater than or equal to minus 5 by 2. X greater than or equal to 5 by 2 fits with x greater than or equal to minus 5 by 2. So this is fine. So x equal to 5 by 2 is one possibility. X greater than, which means this is 3, 2.5 onwards. 2.5 onwards. So this is 2, sorry, 5 plus minus 1, this is 2. There will be 2.5 will be out here, 2.5 onwards. The last part. Rajiv, the last part that I said is basically that I get one side of the range in which I have to look for the minimum value is x greater than or equal to 5 by 2, because mod of 2x plus 5 will become 2x plus 5 when x is greater than minus 5 by 2. So I get 2x plus 5 greater than or equal to 10 or x is greater than or equal to 5 by 2. Is that clear, Rajiv? I repeat, mod of 2x plus 5 equal to 2x plus 5 when x is greater than or equal to minus 5 by 2. Is that clear, Rajiv? That's all. Similarly, mod of 2x plus 5, that is when 2x plus 5 is greater than 0. We want 2x plus 5 to be greater than or equal to 0, which means x must be greater than or equal to minus 5 by 2. Is that clear, Rajiv? Divyanshu? Okay. So if 2x plus 5 will be equal to minus 2x minus 5 when x is less than or equal to minus 5 by 2. Okay, when x is less than that, it will be minus 2x minus 5. Okay, that is the basic point out there. So when x, so it's out here. Okay, and but when x is less than or equal to minus 5 by 2, okay, it is, okay, now it is, we have minus 2x minus 5 greater than or equal to 10 or minus 2x greater than or equal to 15 or x less than or equal to minus 7.5. This is what I get. X less than or equal to minus 7.5. So I have to go all the way somewhere here and go out there. When x is less than minus 7.5. Can we write minus 10 less than 2x plus 5 less than or equal to 10? So that we are more interested in the range of x in which we are looking. Because we are interested in which x will be the minimum value of this expression, x square minus 4x plus 5. So that's why I reach a left hand side border of 2.5 here and a right hand side border of minus 7.5 here. Anything less than minus 7.5, f of x will only keep going up. But out here, it's already at a very high value because it's far away from the lowest point, which is x equal to 2. Whereas 2.5 is very close to 2 and is more likely to yield a minimum. So all I have to find is f of 2.5, which is just 6.25 minus 10 minus 5, which becomes 8.75 minus 8.7 because it's minus 15 plus 6.25. Okay. Sundar, minimum occurs at x equal to 2, which is in that range, but x equal to 2 is not included when I take mod of 2x plus 5 is greater than or equal to 10, remember. It comes outside that range. Please note, Sundar, that when I take mod of 2x plus 5 greater than or equal to 10, I get x greater than or equal to 5 by 2 or x less than or equal to minus 15 by 2. X equal to 2 lies outside these two ranges, so I can't take it. So I have to take either this or this. Why can't minimum at 3? Minimum is not at 3 because f of x equal to 0 at x equal to 5 and x equal to minus 1. Minimum will always occur at the average of the two roots. Remember, minimum will always occur at the average of the two zeros. Minimum of a quadratic expression will always occur at the average of the two zeros. So, coming back to Sudeep's question, Sudeep, the point is your allowable ranges are x less than or equal to minus 15 by 2 and x greater than or equal to 5 by 2. The value of f of x I get at x equal to minus 15 by 2 is greater than the value I get at x equal to 5 by 2 simply because I have a quadratic expression which goes like this, right? This is at x equal to 2. This is at x equal to 2.5. 7. If it's at 0 at minus 1, at minus 7.5 it must be greater than 0. This is at x equal to minus 7.5. So the entire range x less than minus 7.5, it will be greater than whatever it will be at 2.5 because at 2.5 it has to be negative because it's only at 5 that it becomes 0. That is why 2.5 it must be negative and that's why 2.5 of all the values we have will be the minimum. So the answer will be minus 8.75. Okay. So this is the basic point to this question. Okay. Let's move on. One more method, tell me if wrong. Minimum value in the sense is 2x plus 5 equal to 10. We are getting at the boundary, yes. Yes, Rajeev, we are getting at the boundary. We are getting it at the boundary, yes. Sandeepan, there is no difficulty in drawing the equation of the quadratic because you can see it here. And we know the property of the quadratic expression. That is, zeros will occur, there will be two zeros and the minimum or the maximum will always be at the average of the two zeros. That much is known. The answer is 8.75. I worked it out. I worked it out here. It's 8.75. How many solutions are possible? Using how many different concepts of this question can be asked? The minimum value can come only in one way here, Rajesh. Harsha, you can't take 2. Yes, you can't take 2 because 2 comes outside the range where 2x plus 5, mod of 2x plus 5 is greater than or equal to 10. At x equal to 2, mod of 2x plus 5 becomes equal to 9. It's not greater than or equal to 10. So I can't take it. Correct. Because modulus is involved, because I am excluding a certain range, I can't take it. Correct, Arpan. That's where the care is required. Why not x equal to 3? Because I don't get the lowest value at x equal to 3 will be greater than the value at x equal to 2.5 because from 2.5 onwards it is an increasing function. Okay, so that's why. Okay, let's move to the next one. 2 minutes to attempt this. Deepak, yes, you can, but it's easier to imagine it as average of the two zeros. Okay, Deepak, it's wrong. For the same reason I said 2 is not included. Because that's what you're supposed to solve. Okay, I'm going to stop it here. So how do we proceed with this? Once again, we are looking at how to break up the modulus function, right? So I have to look at the area. What is the figure? How do I get the figure? When I look at 2x plus y equal to 6, the intercept form of this is x by 3 plus y by 6 equal to 0, which means when x equal to 3 comma 0 and 0 comma 6 get included. Okay, so that's all. So now what do I do? But then I also have minus 3 comma 0 and 0 comma minus 6. So these points get included. What is the one? Where is it saying 1, guys? Sorry, not 0, 1. Okay, fine, 1. I'm sorry. I think it's too late in the night. I think I'm getting sleepy. X by 3 plus y by 6 equal to, yeah, I divided by 6 and I put 0 on the other side, my silly mistake. Okay, intercept form. So that's, and then my straight lines would have to be of this kind. This is the region I would form. Okay, so this is the region I would form, and clearly y would be minus 3, 0, because when x is less than 0, mod of 2x will become minus 2x plus y. When y is greater than y is less than 0, mod y would become minus y. So I will get 4 combinations: 2x plus y, 2x minus y, minus 2x plus y, and minus 2x minus y, and each of them equal to 1. So in that I get the slope-intercept form of the equal to 6, right? So I would get a slope-intercept form of the equation, and I would get 4 different curves of this kind. So this is the region formed. So clearly the area is nothing but 4 times the area of this triangle, which means half into 3 into 6, which is 9. So 9 into 6, 9 into 4, 36 is the answer. So it's either A or C. Next is the number of points. I just need to look at the number of points on this line, and in between. So I just need to look at how many integer values would come on this line. So it's a question of count. It's a counting exercise, nothing more than that. So minus 3 comma 0, 0 comma 6. How many would come? You can just look at each quarter, inside each quarter, and multiply by 4. In the meantime, I have 1 to 6, minus 1 to minus 6. So there's 12 along this, 3 along this, 3 along this, so 6. So I have 12 plus 6 plus 1. Right? I already have that many points on the straight line itself. So the axis, exactly, that's my point. On the axis I get 19, so it can't be 15, so I won't count and I'll say 31. Correct point. Correct. Who was that? Sanjay, that's the correct way to look at it. I won't waste time anymore. Exactly what I was going to do. The moment I saw 12 plus 6 plus 1, I saw 19. Arey yaar, why will I count all these points in between? Chinmoy, which part? Which part, Chinmoy? How these 4 lines come up? Oh, counting. Okay, counting. I have 0, I have 0 comma 1 to 0 comma 6 out here. 6 points. Minus 1 to minus 6. 6 points. So 12 along this axis, excluding 0 comma 0. Then minus 1 to minus 3, 1 to 3. So 3 on this side, 3 on this side, 6 on the x-axis. And 1 for 0 comma 0. So 12 plus 6 plus 1 is 90. So the number of points can only be more than 90. It can't be less than 19. So it can't be 15. So it must be 31. Tough question, Shruti. Tough question. When we say within the region, within normally, unless explicitly specified, does not exclude the boundary point. That's my basic take on that. Okay. Okay. If the answer options are closed, how do we find the boundary point inside? Okay, finding the boundary point, let's understand this. When I have 2x plus y equal to 6. Okay, let's first get a grip on what would be the integer boundary point out here. I have x is equal to 6 minus y by 2. We're going to use special equations, right? When I take 6 minus y by 2, please remember that there are exactly 3 values of y for which x will be an integer. So I will find 2 points on this line, right? The 2 points are, what are they? This is minus 3 comma 0. So this is comma 2. When y is 2, x will be minus 2. When y is 4, x will be minus 1. So that's how it will come, right? So I'll get 1, 2, 3, 12 points on the outer boundary. But these points are already counted, so I get 8 additional points on the outer boundary. That's 1. Okay. Now I have 2 comma minus 2. Now what do I have inside? 1 comma 1 will come. Look at 1. At 1 and at 2. Okay, look at that. At 1, I will 1 comma 1, 1 comma 2, and 1 comma 3. Here I will get 2 comma 1. So I get 3 plus 1, 4. Is that clear? That's how I would count. So I would have at 2, I would have 2 comma 1 and 2 comma 2. But 2 comma 2 is already counted on the outer boundary. Right? So I will count only 2 comma 1 in additional. At 1, I would have 1 comma 1 going upwards. I would also have 1 comma 0. I have 1 comma 0, 1 comma 1, 1 comma 2, 1 comma 3. So 1 comma 4 is already included. And then I'll go down 1 comma minus 1, 1 comma minus 2, 1 comma minus 3. So I have 1 plus 3 plus 3. 7 points at 1, 7 points at minus 1. Then I have 3 points at 2 and 3 points at minus 2. So I get 20 added actually speaking. I get a lot of points added out there inside. Okay, this is one more question, right? This is one more question I'm going to take up, but that's going to be the most challenging of all. Why would the boundary? It's with see, Jessica, the basic point is it had to be excluded. That's all. No, Prajwal, the point is 2 comma 2 and 2 comma minus are already included on the boundary. Yes, the session is getting recorded, Prasad. Okay, the last question for the day. I'm going to give you 3 minutes. Yes, Amir, your question is valid. It's over n only. I took it from CAT 2003. Vikram, I took it from CAT 2003. Okay, fine. So I'll stop it here. Let's take a quick look at it. So how do we work this out? The simple trick, as I could see it out here when I tried solving this for the first time, we look at the numerator. It has an n square, 2n root n plus 8 root n plus 16, and the denominator has n plus 4 root n plus 4. So somewhere root n is coming everywhere. So let me try to write it in terms of root n. Root n whole power 4 plus twice root n whole cube plus 8 root n plus 16. Right? So that's what I'm getting out here. So what about the denominator? The denominator is where I'm getting root n the whole square plus twice 2 into root n plus 2 square. If I take the denominator, I'm going to rewrite it. I'm going to write as 2 cube, 2 power 4 and 2. Why am I doing this? Because if I take root n to be say x, this expression then translates to x power 4 plus 2x cube plus 8x or 2 cube x plus 2 power 4 by it becomes x plus root 2 whole square, which is what it becomes, right? X plus root 2, x plus 2 the whole square, sorry, x plus 2 the whole square. It becomes x plus 2 the whole square, where x is replaces root n, that's all. And what do I get here? I have x power 4 plus 2x cube and 2 cube x and 2 power 4, which means x is only extra out here. So I have x cube into x plus 2 plus 2 cube into x plus 2 by x plus 2 the whole square, which becomes x cube plus 2 cube into x plus 2 by x plus 2 the whole square, and cancelling this and knowing that x cube plus 2 cube is x plus 2 into x squared plus 2x plus 2 by x plus 2, I simplify this, which means that my expression is n. If I go to the previous one, n plus 2 root n plus 2, that's all, n plus 2 root n plus 2. This is my expression. Okay, so that's the way it works. N plus 2 root n plus 2 is what I'm getting out here. And how do I simplify this? Okay. Okay. Explain one more time. The point is the simplification starts out here. When I come to this, I recognize this as root n whole power 4, 2 root n cube, 2 cube root n, and 2 power 4. Okay. Which one here? Why are you pulling my legs, Ayush? Let me come back to that. So there are these two things, root n whole power 4, 2 root n cube, and then when I come to the penultimate line, come out here, it's x power 4, 2x cube, 2 cube x, and 2 power 4, and x plus 2 the whole square. Okay. So x cube into x plus 2, 2 cube into x plus 2, which means x cube plus 2 cube. Oh, this is minus 2x. Yeah, minus 2x. Thank you. Yeah, I did miss that out. These errors are common even if I'm not speaking. Don't worry. Yeah, minus 2x. So this x plus 2 gets cancelled, and it gets cancelled twice. The denominator x plus 2 goes completely. That's the basic point. Okay, so I get a minus 2n out here. So it becomes n plus 2 minus 2 root n. So how do we simplify this? Okay. And what is my range out there? My range is 36 to 72, right? My range is 36 to 72. 36 less than n less than 72. So I just need to substitute out here now. That's all. I'm just going to have to substitute. So at one level, what do I have? I have n, which is 36. So I have 36 minus 12 plus 2, which is 28. 12 plus 2 or 12 plus 4? 4, sorry. 4. That's the point where I said I'm sleepy, right? Correct. Plus 4. So it's plus 4, so it's 28. And on the other side, it's 72. It would just become what? 36 root 2 minus 12 root 2 plus 4. So 24 root 2 plus 4 is what? 72. I take 72 and minus 72 minus 72 minus 12 root. The root comes only here plus 4. So it is 68 minus 12 root 2. Right, 76. 76 minus 12 root 2. Root 2 being 1.4142135562. So 12 into 14, 168. So roughly 16.8. So 16.8 subtracted from 76 is 59 point something. So when I go back to the answer choices, what do I see out there? The only answer choice that comes close is 60. I can't take 58 because it's between 59 and 60. We can take 64 for root of n. I don't know. Okay. Vignesh, the problem is that when I first worked it out and took an approximation, I got less than 58 as possible. It's only when I worked it out properly that I got something between 59 and 60. That's all. Because something that is greater than 23 is also greater than 20. That's greater than 28 is also greater than 23. That's why I had to do it from the other side. That's the idea. You should check the narrow range, but what if it is less than 58? Then I could be torn between these two options. So answer D is the correct one, but that's because the upper range lies between 59 and 60. That's why. Okay? N equal to 64, you get 52 and 48, but I'm supposed to put N equal to the maximum range. Okay, the point is, when I look at this expression, its value would be maximum at the highest range of 72, at the highest range. Why would it be maximum at the highest range? Anybody? Why would it be maximum at the highest end of the range? Okay, let me go through that again. N minus 2 root n plus 4. So why would it be maximum at the higher end of the range? because it is n minus 2 root n plus 4 is nothing but n minus 2 root n plus 1 plus 3, which is root n minus 1 the whole square plus 3. That's all. Right? So the whole point is root n minus 1 is maximized at the outer end of the range, to which I am adding only a 3. So looking at the outer end of the range is what makes sense. There is no question of an intermediate value giving us a higher value of this expression. Is that clear? That is why we need to be 100% clear that only the outermost point of the range will give the maximum value and the innermost point, leftmost point of the range will give the minimum value. Because it is root of n minus 1 the whole square plus 3. Don't forget that. Okay, the moment you see this, suddenly one bulb will go and you realize, oh my goodness, that's how I read that. Okay, sorry, that is the whole idea. The whole idea was not to demoralize anyone. When n is 64, the value is 62. N is 64, the value is 62. 64 minus 2 root 64 plus 4. 64 minus 18 plus 4. How is it? 52. Correct. So less than is 48. No, it's 50. 68. It's 68 minus 18. 50. Okay, forget it. So it's not working out. So don't rack your brain. No, it has to be. See, this simple explanation that I gave, which is root of n minus 1 the whole square plus 3, that should tell you it has to come at the outer end. That's all. 16. Oh my goodness, I'm so sleepy. 16. Yes, so it's 52. Fine. Thank you. Okay, the simplification, this one. Okay, just look at this. I'm just breaking up 4 into 1 plus 3. Is this simplification or the previous simplification, Gayatri? This one. Oh, sorry. This one, right? No, this is the previous one. I go to 17th slide. Okay, out here. This one. Okay, I started here. Okay, what did I say here? That first note that I started with this root n power 4, 2 root n the whole cube. So where did I go from there? 30th slide. Okay. Here, yeah, correct. X power 4 plus 2x cube plus 2 cube x plus 2 power 4 by x plus 2 the whole square. Is this part clear? Yes, this was the last question, didn't I? So you may leave if you want to leave now. Now, Gayatri, what did I do? I looked at these two. I look at these two. What do I see? X cube is common. I can take it out and I have x plus 2. Double note, it wouldn't be that difficult that we should skip it. A little focus can get it. Okay, so you have 2 cube out here, you take 2 cube and you have x plus 2. That's all, I just factorized it in this manner. So once I get to x cube plus 2 cube into x plus 2 by x plus 2 the whole square, I further factorize x cube plus 2 cube into x plus 2 into x square minus 2x plus 4. And so the x plus 2 gets eliminated completely in the denominator. And therefore, I come to this expression n minus 2 root n plus 4, which is where I get this expression from. Is that clear, Gayatri? Okay. What is the first question? This one. Okay, thanks, Soumik. I didn't realize it. Hemant, just focus on the basic. That's why we took this session, to bring you back to the basic points about handling algebra, which is all about going to the root of it and then applying the principles systematically. There is nothing more. For example, when you talk of inequalities, don't forget that you don't cancel algebraic expressions on the two sides. When it's multiplied, you have to apply the conditions jointly. That's a fundamental and critical aspect of handling inequalities. Most people who goof up there. They cancel expressions on the two sides and then end up wondering, how did I miss this particular possibility? That's how most people goof up in algebra. No, just review. My suggestion, Rajiv, would be review the smart cat questions on algebra. The study material and the smart cat are more than sufficient. To the best of my knowledge, there is nothing more that you need. There is no rocket science coming in the cat. As I told you, even after I skipped some of the really difficult questions in algebra, personally I could find 22 questions easy to handle. Trust me, if you just, the key is to skip difficult questions quickly. I skipped them like this. I read them, I knew they're difficult, and I moved on. You will have review option for every question, Karthik. Actually, Gaurav, I made a mistake in the log question. They don't touch, they actually intersect. Because the log question, the straight line goes like this, the log curve actually goes like this. It goes beyond and then cuts down again. Geometry and arithmetic also, Rajiv, please focus on the smart cat. That's the best way. Geometry especially. Yeah, the sectional test plus smart cat should be more than sufficient. I've seen the cat paper myself. Frankly speaking, I just went into the cat. I just woke up and went in. I haven't done a lot of serious hardcore cat math teaching for a couple of months now. I just slept and I woke up and went and I could find the easy ones easily. Trust me. If you refuse to get scared, you will find enough easy options to do. Just don't go in thinking, oh my goodness, my life is going to be decided here. Go in with a pretty cool frame of mind. Relax, do what you can. Don't worry about the outcome. The more you think about the outcome, the less is going to be the chance of success. Relax, enjoy the show, do what you can, smile and skip when you're not able to do something. Don't get perturbed. There will be enough questions. Multiple selection option, RC to mark some important lines. Vikram, I would suggest, based on my reading, I really don't think you will need to mark important lines. Yeah, Deepan, that's a good idea. That's a good idea. Watch India-Australia series. That's a good way to prepare because at least you will relax a little bit. Not at all a bad idea. Rajiv, it was distributed across areas, but let me tell you one thing. The one thing about geometry was that it looked difficult. No, Karthik, okay, it looked difficult, but when you drew the diagram, you suddenly felt like slapping yourself for thinking it was difficult. That's how I could see many of the questions in geometry. They were deceiving. They're deceiving you. The question looked. It's easy for you to get scared and not see how simple it is. I can't discuss questions, so I'm not doing it. If I discuss the questions, you will agree with me that it was actually, there were questions where I actually read and I thought it's difficult. So, let me draw the diagram, and I drew. And after the question, I said, after drawing, I said, don't tell me this is a cat question. So that's how it was. So don't get scared. If you refuse to get scared, you will find enough simple questions in the cat paper. Bear that in mind. Hemant, I don't think so. I gave the cat on first day, first show, and I don't agree. In fact, I would go the other way. Or the five questions I faced, probably 4 looked difficult but were simple. Deepshika has been doing that all this while. And I tell you, about 5 questions were there in geometry and 4 to 5 questions, and they were distributed across areas, but that they were deceptively simple, appearing difficult, but actually easy. I think there was a little bit of DS here in that pattern, but not too many. Karthik, if your question is what should I do, my suggestion would normally be to get done with the areas of your strength first so that you reserve time for the areas of your weakness later. Sangram, DI was, while you say calculation intensive, there were enough questions where you could answer with just quick comparison and approximation, not too much detailed calculation. Subhanil, there were a few questions on DS in some papers, maybe one. I really don't recollect, actually I don't recollect any DS question in my paper. Reasoning part was actually quite simple. There was one question in my set which Raghunath sir confirmed today. That day I felt something is wrong in this question. He told me the same thing that, yeah, something is wrong in this question. So I could see that there's one question with an error clearly. The answer choices didn't make sense. Was any set of DI straightforward? Rajiv, every set of DI was straightforward. Every set of DI was straightforward, so don't get too scared by DI. But when you go and it becomes difficult, don't get worried because it means that they have adjusted it. So don't go in with preconceived notions. At the same time, don't go in with big fears that this will be difficult or that will be difficult. Prajwal, number 2, it was a mix of easy and difficult questions. So don't get perturbed. Just go search what you find easy. Just do what you find difficult, skip quickly and go on. What about marks for error questions? Harsh, don't get too greedy. They will do whatever correction they will do. That's all. You do what you can. Don't put any burden of expectations on them. Today's questions. So I didn't really look at the CAT pattern because I do not want to bring the CAT pattern into this discussion. That would be wrong on my part and unfair as well. So I'm not doing it. I'm only using questions to revise concepts. Okay. So good night, everybody. Let's all the best, and I definitely look forward to seeing more of you at the GDPI speech. Thank you. Absolutely, the art of skipping questions, very critical.